Welcome to the second lecture on computational geometry. Today we will talk about map overlay or line segment intersection. If we have a map, then we usually want to have some features that we want to highlight. For example, I have a map here and we have highlighted some cities. Or we can highlight some rivers, or we can highlight some streets. Most of the time we want to combine them. We don't only want one of those, but we want to combine them all to a single map. And that's something that you do in geographic information systems. That's called map overlay. We want to overlay all the streets, rivers, and cities, and whatever else we want to show on a single map. Now there can be some interesting tasks to do here. For example, if I have all the roads and I have all the rivers, then I can also quickly find all the bridges. Wherever we have a road that meets a river, there must be a bridge there. The question, however, is, how do I do this quickly? How can I quickly scan the map and find all the bridges in the map? And this is where line intersection comes into play. If we are given all the roads and all the rivers as polylines, then we only have to intersect all the line segments that they consist of. And for every intersection point we find, we can place a bridge there. And the question is for us, how do we do this line segment intersection quickly? There are a few things we have to consider. The first one is, let's assume we have these two line segments. When the endpoint of one of the segments lies exactly in the middle of one other segment, do we count this or do we not? This is a question of definition. It depends on how we define our line segments. In this lecture we consider our line segments to be closed. So in this problem we are given a set S of n closed non-overlapping line segments in the plane. So it cannot be that you have a river that's below a road, and you also cannot have two roads that are above each other. Then we will only model them as a single road. And what do we want to compute? We want to compute all points where at least two segments intersect, and for each such point we want to report all those segments that contain it. And this gives us the bridges, and it also tells us which road crosses which river at which bridge. So since we have closed line segments and the endpoints belong to the segment, that means, yes, for us this is indeed an intersection. How would you solve this problem? Let's have a look at an example. We have a set of line segments here. We have this line segment, this one, and so on. This is a very special case already, because we have this point here, that's the endpoint of this line segment and of this line segment. But it also lies in the middle of this segment and in the middle of this segment. So we also want to report this point. So all the intersections that we want to compute are this intersection point here and this intersection point here. These are the two intersection points. And for this point we want to report these two segments. And for this point here we want to report all these four segments. Again, how do we compute this? One way to do it is just brute force. Take any pair of segments and compare them and figure out if they intersect. How long does this take? We have n segments. We have to compare each pair, so we have to compare every segment with n minus one other segments. So this takes order of n squared time in total. But can we do better? Order of n squared time is a bit slow. And I told you in the last lecture my favorite running time is order of n log n. So I would like to get an algorithm that does it in order of n log n time. Do you have any idea how we could try to do this? Well, the idea that I want to talk about here is a sweep line. We want to process the segments top to bottom using a sweep line. Because this segment and this segment down here, we don't really have to compute if they intersect, because clearly this one is above the other one. So if we go from top to bottom and we have completely processed the segment here, we don't really have to look at it again when we go down to the other segments. And this is the basic idea behind a sweep line. And how it exactly works, that we will do in the second part.